Hey everyone, and welcome to Deep Learning Prerequisites, the NumPy stack in Python. In this lecture, I'm going to introduce you to the course, tell you why I made it, and what you should expect to get out of it. This is the course you want to start from if you are new to my courses, or if you want to learn machine learning but you don't know where to start. So first, let's talk about the title of this course. What does it mean? The NumPy stack in Python. I like to think of it like how web developers think of stacks. They have the lamp stack and the mean stack, so us data scientists should have a stack too. And that stack is the NumPy stack. LAMP stands for Linux, Apache, MySQL, and PHP. These are technologies that all work together and complement one another so that it becomes very easy for you, the developer, to build a fully featured website. Similarly, the NumPy stack is a set of technologies that will enable you, the data scientist, to efficiently perform all stages of a data project, including gathering and manipulating data, exploratory data analysis, visualizing data, and finally, implementing algorithms and models to make useful inferences from your data. So what are these technologies that make up the NumPy stack? Well, actually there are plenty, but the ones I'm going to cover in this course are the fundamentals: NumPy, Matplotlib, SciPy, and Pandas. These are a set of libraries that work together in unison to help you do useful data science tasks in Python. Now, you might wonder, why is it called the NumPy stack and not the Matplotlib stack? Well, the reason for that is NumPy forms the core of all these technologies by giving us the NumPy array. The NumPy array is a fundamental data structure that can represent vectors, matrices, and multidimensional tensors. These are the raw materials that data scientists work with. So what can we do with these raw materials? Well, using Matplotlib, one thing we can do is visualize our data by making useful plots, like the scatter plot. With SciPy, we can do statistics with our data, such as significance testing. Of course, SciPy can do a lot of useful things other than statistics, but you'll just have to wait and see what they are. Pandas is a library that makes reading, writing, and manipulating data very easy and very efficient. Now, to get to a more important topic, why does this course exist? Today, I have over 25 machine learning and artificial intelligence courses. Why am I making a course on libraries like NumPy? Well, here's what I noticed in my years of teaching. I noticed that there is a gap in knowledge when it comes to building machine learning models. Often, building machine learning models is made up of two steps. The first step is the theory. Understand the concepts and apply those concepts to derive an algorithm. That's the kind of stuff that you might get from a book or a journal paper or a typical course on machine learning. The second step is to put that theory into code. Often, this is a translation of mathematical equations programmed into a computer. Well, the gap I noticed was that students doing machine learning had very little idea of how to put that math into code. And doing math in code is pretty much exactly what the NumPy library is for, and hence, it is the central theme of this course. By the way, I do want to take this opportunity to mention that this course does not discuss machine learning itself. This is not a machine learning course. It is a course that builds up some prerequisites to machine learning. Of course, that makes total sense, given that I already have 25 courses on various machine learning topics. So understand where this course fits in terms of learning machine learning. You should now understand precisely why this course has the title it has. It's called Deep Learning Prerequisites because it's going to teach you a lot of the skills that you need in NumPy, Matplotlib, and so on, so that you can actually build deep learning and machine learning algorithms after you learn about them in the future. At this point, I want to talk about what I expect from you. You, as a student of this course, have some responsibilities. I hope they are not too demanding. First, I expect you to meet the prerequisites of this course. That means know a little bit of linear algebra and know a little bit of probability, just so that you understand what I'm talking about. The reason for that is, we are going to be applying these libraries to do some linear algebra and probability, and obviously we can't do that if you don't know what they are in the first place. Now, some of you might ask, why don't I teach you linear algebra and probability? Well, first, these are two separate full semester courses, and obviously we can't just inherit two separate courses into this single free course. And of course, you'll inevitably get the student who will ask, yeah, but what about me? I still need the prerequisites for probability. Okay, so then we do the prerequisites for probability so that you can do probability, which is itself a prerequisite to this course, which is itself a prerequisite to machine learning. As you can see, this can get wildly out of hand very easily. And that's why I depend on you to follow the prerequisites as instructed. Oh, and there's one more thing you need to know, which is Python programming. This is for the simple reason that everything in this course will build on your existing Python programming knowledge. And if you don't know Python to begin with, then we have nothing to build on. Trying to implement machine learning algorithms in Python without knowing how to program first would be like trying to read Shakespeare without knowing how to spell. Now, there's one more very important thing I expect from you. I don't want you ever wondering, how are you going to practice what you learn in this course? And that's because I'm going to answer that question for you right now. Remember that the real purpose of this course is to learn some of the basic building blocks that you need in order to do actual machine learning. These are the very basics, just enough to get you started. There won't be anything very advanced in this course, because you will learn enough now to get you going, and then you can take care of other things later. So what should you do to actually put what you learned in this course to work? Well, you should actually go out, learn machine learning, and implement the algorithms you learned. A lot of people say, oh, but I can just use scikit-learn to do machine learning. Why would I ever need to implement a machine learning algorithm myself? If this is you, then I have 2 words of advice for you. Number 1, you probably don't need this course if you never plan on implementing a machine learning algorithm. And number 2, you should probably think twice about your approach, because there are thousands of computer science graduates entering the professional world every single year who can, and they are your competition. If you want proof of that, you can email me anytime and I will gladly demonstrate that to you. So how do you practice what you learn in this course? Yes, I do have a few exercises in this course, but these are not the real exercises that you should be doing. Realize that this is just the beginning of your machine learning education. Your next step is to learn actual machine learning and to make sure you understand what you've learned by putting what you've learned into code. My motto has been and always will be, if you can't implement it, then you don't understand it. You don't get points simply for believing in yourself. Thanks for listening, and I'll see you in the next lecture.